company called Impetus, and I manage the product business for a product that we have put out there. It's went GA in February. It's called Stream Analytics, and this talks basically a use case pattern around that platform. And I promise not to make it a sales pitch. It's going to be more about the concept of a smart enterprise big data bus, but we'll also talk about the fulfillment of it towards the end. So just so that you know who you are speaking to in terms of the company, Impetus Technologies has been a big data solutions provider since probably 7-8 years. We're one of the first companies in the SI space to get in and start implementing large-scale big data solutions for huge enterprise customers, credit card companies, financial services, telco, et cetera. And as we have done our implementations, we've learned a lot, and we have found products that are needed, that are not available, and built those as we have come along the journey. And one of that is this Stream Analytics platform, which is the core of this whole enterprise big data bus technology that I'm going to be talking about. So we went GA in February 2015, and today we are, of course, sharing one of the use case patterns that's enabled by this product. So thank you. And if you are, just so that we get some interactivity, I walked around the audience and met some of you. Raise your hand if you are, in fact, actually trying to build an enterprise data bus that connects multiple silos in your organization. Okay, super, great, thanks. So let's look at the why, the what, and the how, and then get to questions and some interaction. Feel free to interact as much as you want. And I'm going to try and end it about 5-6 minutes before the session completes so that we get to talk. So why? Let's start with the real case study. Guess I jumped a little ahead. So we were implementing Stream Analytics in this large healthcare insurance company, one of the largest in the country. And they have already chosen an enterprise NoSQL database for all its virtues, and they're hosting all of their internal applications on that enterprise NoSQL database. It is not open source. It is a commercial product, but it offers them what they need. So they're building out their whole suite of applications on this enterprise NoSQL product, and they're also committed to Hadoop on the other side. So they've built out a complete data pipeline that does ETL and lands data into Hadoop. They use multiple Hadoop distributions. But as we were talking about streaming analytics and what makes possible for them, we didn't really anticipate this use case, but they said, look, we've implemented this big Hadoop infrastructure. We've chosen this enterprise NoSQL database, and all our internal applications and analysts and decision makers are looking at this platform. And obviously, there's going to be some sort of batch process that syncs both up, probably once every day. Now, they're dealing with insurance claims and things like that, and they clearly are committed to accelerating the business process. So one of the things they want to do is, catch fraudulent claims as soon as possible. Process these claims ASAP, and when a claim data comes in and lands on Hadoop, they just said, look, I don't want to wait for many hours. I want to sync it up to my NoSQL database ASAP as it comes in. And on the way, I also want to do some streaming transformations. I want to take the date field. I want to cut off the string. I want to do some data pre-processing so that I land the data in a way that that set of applications on that NoSQL database is expecting. And we didn't think of it as like, this rocket science streaming analytics use case, but it was useful to do that, and it dramatically improved their business process because everything that's coming in landed in the right place, in the right format, when the analysts needed it in near real time. So we basically ended up building a point-to-point synchronization, real-time synchronization capability, and not just data synchronization moving, but also being able to transpose it, transform it into the right format as expected by the application on the other side. So now if you take this pattern and expand it out, so this was one big application portfolio, but they have multiple. And in all large enterprises, or even in medium enterprises, if you're dealing with, instead of that one NoSQL, if you had multiple, you have to synchronize all of that. And so that becomes the more generic problem to solve. And that's what is solved by this enterprise data bus, right? So let me come to build up the story. So there are three drivers for what we feel is the need for this. One is Hadoop is becoming the center of the data universe in the enterprise, right? Hadoop does everything. It makes coffee too, I guess. Sometime in the future it's possible. It's an active archive. It's an ETL platform. It acts as a single source of truth, BI plus analytics, high-speed analytics, SQL on Hadoop, and now streaming and transactions on Hadoop, recursive programs like graph databases on Yarn. All of that is possible, right? So we clearly are seeing a worldwide adoption of Hadoop. And if you look at the distributions, I'm going to go through all of them, right? You'll see a common pattern. The file system, Yarn on top, and then the different types of workloads, starting from batch processing to SQL to machine learning, stream processing, and all of that. That is the Cloudera picture. The Hortonworks picture is very similar in its core, but then they've added security, operations, governance, and all of that. And these pictures were probably a couple of months old from their website, right? So this is the focus on the centerpiece, which is all of the applications or workload types sitting on Yarn, sitting on a Hadoop cluster. And MapR has a very similar picture. And again, all of these pictures were taken out of their websites. So if you look at all of these three pictures and architecture diagrams and compare it to the reality in an enterprise, what is missing? What do you think? What else do you think should be addressed? Anybody? Legacy. Okay, great. Huh? Integration, right? Yeah. That's precisely right. So when we go into on the field and do big data implementations, it's not sufficient to just be all enthused about Hadoop and installing Hadoop. We've got to worry about all of the surrounding pieces of integration. So how Hadoop connects to the rest of it all and the issues related to that is obviously something to be considered. Now, we started with the case study of enterprise NoSQL database synchronizing with Hadoop in this large tier 1 healthcare company. And this company has actually been recognized as a leader in analytics, right? So if a leader in analytics, if the tier 1 player in a particular space as important as healthcare is having this issue, we figured it is probably a general problem to solve. So the focus here is you got Hadoop installed, you got a couple of use cases going, but then look at the long term. You've got to be able to connect all of the pieces around in the ecosystem to Hadoop and have that be in sync all the time. So the data integration challenge in developing, managing, and maintaining this hub and spoke system around Hadoop is obviously going to be an ongoing issue. And that's probably the reason why the services side of the business around Hadoop is probably 4 to 5x in terms of revenue around Hadoop revenue itself, right? So, welcome, John. So, the second important driver is business critical applications are still silos. So, if you did an online banking transaction yesterday or today, or in the day before yesterday, do you think that transaction came out of HBase? Or, yeah, no, right? If you interacted with the call center person in the last week, do you think that application was sitting on Hadoop? It wasn't. And it's not going to be for a while. So there are big fat server farms hosting large applications in the enterprise that are going to be sitting on its own database, which is not based on the Hadoop stack. And probably they have a roadmap for 5 years to port everything onto a big data platform. But for many years, you're still stuck with these silos of large, huge applications and databases around the enterprise actually doing mission critical stuff with customers. So thereby it's not a transient problem. You really have to have a solid, robust architectural approach to synchronizing all of these data silos with Hadoop and The third driver, why you should be doing that. So I'm just reiterating the whole data integration challenge here, the hub and spoke architecture that is going to be around. It's a reality that needs to be dealt with, that needs to be solved. The third driver is real-time streaming and analytics adoption is rapidly increasing. If you saw the keynotes today, there were so many talks about, so many instances and referrals to streaming analytics success stories of pretty much everything needing to be real-time. So there are two drivers again. Business operations needs to get real-time. Customer analytics needs to become context. The customer interface needs to become context aware, right? So everything that the customer touches needs to be context aware. If you spend time on a website, picked up the phone, and called a call center, does that call center agent get what you did just now on the website? Probably not. But would it be great if they had the information? That's what you need for a context-sensitive enterprise, right? Moreover, there are other things like mobile location-based offers, internet advertisements, call center agent interactions. All of these touch points with the customer need the enterprise to be modern, responsive, and agile. And obviously, when you do take the information from all of the channels that the customer is interacting with, harmonize all of that, synchronize all of that in real time, and provide context-sensitive service, it makes a difference. Customers stick, we don't churn, we don't leave the provider, and we give more revenue, and they get more money, and we are happy, everything is fine. So that would be a driver, again, to move forward from your batch workflows that synchronize data only once a day, at best, right? Or even if it's happening once in many hours, why not go to that next paradigm of real-time synchronization? Now, we talked about one problem, which is synchronizing Hadoop with everything else. But maybe we also need to synchronize some of those applications with each other. Like we just talked about, a web interaction and then a call center interaction. Now, that has to synchronize with each other to get the context, right? For one end for the left hand to have the context of what the right hand did, again, it's possible that you might want to have some of that, at least some of that data go through immediately from one application to another application if it is customer critical, and you want to really drive that context over to other customer-facing parts of the enterprise. So you have really kind of an n-square problem here of data synchronization, and it needs to happen at scale, and it needs to happen in real time, and it needs to be reliable, and it needs to be compliant with governance and all of that. So that we see is an emerging problem that will continue to be solved in different approaches. We have one approach to solve that. And so what would be a solution? I mean, it's pretty intuitive from the topic, right? So a high-speed big data bus architecture would be an efficient any-to-any data synchronization mechanism. Now, what would be the characteristics of that? You've got to be able to literally draw a line and connect one system to another. Put some rules and say, okay, my MarkLogic database will synchronize with my MapR file system, or or my Hortonworks Hadoop installation will synchronize with my Oracle database. So you've got to be able to draw those lines. So arbitrary connections between major installations of data and applications, and ideally, you would want to put rules on top of that, which is this application needs data in a different format, so you need to actually do transformation on the wire. You need to process, when you're processing real-time data and there is some business critical information, you want to raise alerts. You want to have business logic that applies on and that is watching all of the data coming through. So this would probably be a great solution. And again, like, the bus is an age-old, the oldest concept in computer architecture, right? It's nothing new, but I think it has a different implication and different demands now in the modern enterprise. So what might be the capabilities of this thing? You've obviously got to ingest data, parse all the information, being able to filter so that you can selectively apply different fields and send only the relevant data to the right application. You obviously want a full-fledged transformation capability on the wire. you obviously want to move the data from point A to point B on demand very easily and manage and monitor all of that. You want to obviously be able to, if you're ingesting real-time data, you want to store it arbitrarily into any location of your choice. You have to have a read-write capability with all your major installations. Again, synchronizing, we've been asked about change data capture, for example, very often by many customers, where they want to start synchronizing Oracle transactions as they come in with HBase. So, and then it would be really cool if we don't just stop at that, but also actually put stream processing and analytics capability on the same infrastructure. So you can actually now start predicting, you can start looking at security events, you can start looking at fraud detection, all of that in real time on the same infrastructure. So a data integration platform across the enterprise and an analytics platform together on the same infrastructure. Obviously, all of that has to happen at scale and fast. So that would be a solution pattern and the kind of functionality that needs to be on this thing. And we've kind of envisioned this in this way, which is the Smart Enterprise Big Data Bus, where really this is an information highway in the enterprise where all the stations, the data stations are Hadoop, your business applications, your EDW, ADW, your web server, all of the major data consumers and data generators are stations on the bus, and there's read-write adapters reading and writing from each of those. You ingest all your data streaming sources on one side, and then interconnect that on the other side to any system. So on the top, you have all of the data stations, and on the bottom, you have all the services available on the bus in a convenient, visual, manageable way that you can manage at scale, operate at scale, and easily, right, with a good user experience. So you have the ingest and filter, you have transform, transportation, you have analyze, visualize, alerts, triggers, all of that functionality built in on the bus. And naturally, if this is going to be working at that level of scale, you obviously want a certain degree of scalability, fault tolerance, elastic scaling, high availability, et cetera, built into this platform. So that's the vision of what would be an enterprise data bus, and I'm obviously not yet talking about the technology stack. It's possible to implement in many different technology stacks. But there may be a question coming up in your mind, and I'm not sure if this slide is complete in itself. I'm not an ESB expert, but I've talked to a few that are coaching us as far as our customers are concerned. I brought up this question, like, hey, what about ESB, and why doesn't it do this? So, the tentative answers are that ESBs were not architected for this kind of workload. They were not architected for this kind of scale, for big data scale, and to operate that fast. And the flexibility of building a DAG on a bus, I'm not sure if it's available. And it's probably all monolithic type workflows you can create, and if you need to touch anything and break anything down and stop anything, you need to shut down the whole system. So you want to have the flexibility of building a dynamic acyclic graph with multiple workflows, with multiple components that you can scale independently, that you can change, that you can operate differently, that you can shut down and start without shutting down the whole system. There's other aspects of scaling, so I'm not sure if there's the ESB industry was built at a time where they had the ability to do horizontal scaling like what's happening today. So it all becomes a vertical scaling story, which is obviously very, very high cost. So these are some of the issues where we feel that there's no current systems that can do all of this together. This smart enterprise big data bus concept, I think, overlaps with the data integration industry, the ESB industry, and the streaming analytics product category. So it touches on multiple product categories, and I would expect all of these players to start innovating in this direction, I think, and we see some of that evidence. And we are coming from the streaming analytics platform side, which is Stream Analytics, and we are building this kind of functionality to achieve the smart enterprise big data bus that we just talked about. So what are we doing and how does it work? Stream Analytics is an enterprise class streaming analytics system based on open source technologies. As many of you I spoke to in the audience today came in because you're trying to work with Kafka. You're looking at how Kafka can be used in this. How can this particular stack be useful for this particular application, right? So our stack is, we have inbuilt support for Kafka and RabbitMQ. The stream processing engine is currently Apache Storm. We are going to be compatible with Spark streaming as well in later this year. And there's a number of different operators that we've built on Storm that can easily do read-write from different databases and do transformations. And we have already spoken of and published in our website a partnership with a data integration vendor, SyncSort, who's in the room also, so that we can just drag and drop their ETL operator on the data pipeline and do visual ETL on the real-time streaming analytics platform. Real-time dashboards are built in. WebSockets are built in for visualization. We've absorbed a complex event processing system that will act on Storm, so you can actually do complex analytics. You can do stream correlation. You can blend real-time data and historical data on the bus and do analytics. So remember, right, it's not just an enterprise data bus. It is also a streaming analytics platform. It is a full-fledged data transformation, could evolve into a full-fledged data transformation engine as well in real time. So all of that functionality need to be addressed. And it's compatible with NoSQL databases. So we've historically evolved a lot of data abstraction technologies that work on different NoSQL databases in Impetus, and we've used all of that IP as well. Yeah, you had a question?
As far as PMML, what's your support? Are you a consumer, producer?
We will consume PMML and score in real time.
Okay. And how broad is your support for the different algorithms to be scored?
There are about 20 to 30. We actually have integrated the JPMML libraries into Stream Analytics. So everything that the JPMML libraries support, we support. And that is evolving pretty fast. So his question was about PMML, and that came from, in fact, one of the auto industry majors, that they really wanted their data scientists who are building models in R and SAS to be able to export that and score in real time. And one of the things they were looking at is whether if you're behaving a particular way on the website, by what you are doing, can they tell if you are about to buy a car in the next few days, or have you just started exploring? So based on that, they would send you the right promotion. They would send you to a dealership with a discount coupon or something like that to convert you if you were an advanced stage consumer. So that was the use case that drove our support for PMML on this platform. So I'd welcome any other questions, by the way, and keep that interactive. So those are the core capabilities that we built into the platform. And let's see how it looks, right? So we've changed our architecture diagram a little bit, but how this platform looks, and it sits on a stream processing engine right now, Storm. It'll be Storm and Spark. Could be other technologies as well. So you have a bus, you have a data queuing technology coming in, and then you can actually build out any kind of graphs, topologies. If in the Storm language, it'll be topologies. And it fits very well with our partner Hortonworks also. I mean, given that we're in the Hadoop Summit here, we've got to acknowledge that it's a great fit on the Hortonworks platform. It's certified on HTTP 2.2. So if you are a Hortonworks customer, this is a great natural fit. There's a lot of traction in the Hortonworks on the field today where people are trying to use Storm. They want a much better, easier way to build topologies, build applications, and connect different streams. And connect different data points in the enterprise. So this makes it drop dead easy, and I'm going to show you a couple of screenshots as well. So what do you see on this platform? There's a couple of queues that are connected. So the queue can be in the source, the queue can be in the destination side. So you can stream and then queue and then build logical subsystems. We have a nice UI that can help you drag and drop all of this with a real-time dashboard built in. The green circles, the 3 green circles are applications, which are actually DAGs, which are, that you drag and drop, connect, set rules, and it becomes an application. Submit it, it's live, send the stream of data, it processes it. Some of the things that you can drag and drop are your Hdfs connector, your Hdbase connector, something that writes into Elasticsearch, something that reads from a database, something that reads from a file system. So that would be your any-to-any type interface capability that we talked about in the enterprise big data bus architecture. The analytics piece is also important. Somebody's brought up the interest in PMML, so we can drag and drop PMML into the pipeline. You can just upload a PMML file, it'll start scoring in real time. So those are the different capabilities. We have a distributed cache capability with Couchbase, and it can be replaced with any other technology that you might prefer. And those are for distributed state applications where you want to remember things and build a time window-based approach. So you can do event streaming, you can do micro batch, you can do both of those paradigms because you do have access to every single event. So if you have actually got a single insurance claim that came in that needs to be looked at and immediately responded to, that's possible. Or if you want to batch up over 10 minutes, that's possible as well. So that's the overall architecture diagram here, and just a couple of screenshots here. When you drag and drop, this is a screenshot of the system. We have the live demo running in the booth here in S9, booth number S9, where you can see the system, and we'll show you live how you play with it. But essentially what you see in this picture is a workflow, a live workflow. So if you want to build this one particular workflow where you want to read from your NoSQL database, you want to filter the data, you want to transform it, you want to visualize some part of it, you want to set an alert logic, and then you want to write into Hadoop. So all of those tasks, you drag and drop, connect these things in the sequence that you do. You can do parallel tasks, you can do sequential tasks, and submit that job, it'll start running. So after that job is submitted, anything that particular job is supposed to pick up starts getting picked up and starting dropped in the destination, and the transformations that will happen on the wire as you configured it. Okay? So that's an example of how easy we've made to work with the underlying Kafka, Storm, Hadoop technology. So you don't need to have deep down knowledgeable developers that understand all the nuances of each of these technologies. You can literally drag drop. You need some awareness, of course. You can't be completely new to this stack. But we're trying to make it as easy as possible. We're constantly innovating to ensure that any code or scripting you need to do manually is minimized. So you can put custom logic. You might have a convoluted piece of logic that you really need to apply on the data as it comes in, and you have that flexibility. You can actually build a little Java program that takes this, and we normalize all of the data into JSON on the pipeline. So no matter what data comes in on the pipeline, it is JSON. We throw up JSON into your code. You can pick it up, transform it, add new fields, create derived fields, and put it back on the bus, and it'll go. And you can connect it to downstream applications. You can connect alerts to other workflows. So if you want to kick off an IVR call out or an email based on a particular condition, even if the condition is based on a derived field that did not come into the stream, you can do that. And like I said, you have a complex event processing operator there. You can drag and drop. So you can do max, min, statistics, all of that on the incoming data. So this essentially is the way you work with it. You right-click, you configure it. This is the HDFS writer, for example. And obviously, we are catering to real enterprises that need to make stuff happen in reality. So a developer may be satisfied, but then the ops guy has to sign off as well. So we have targeted some of the functionality to the ops guys as well, that they want to monitor the whole thing. They want to see everything and how it works and be alerted automatically if anything's going wrong. So this will be an example of the complete detailed processing, monitoring system on each of those components that we saw earlier. So for example, in this picture, you see the different tasks, and each of those little modules is an operator that is actually scaled out. So you can have 10 instances of that second piece, 5 instances of the third piece, each of them running on different pieces of hardware. You can monitor each instance of that and monitor it, look for hardware errors, look for application errors, all of that. If you want to set an end-to-end SLA, for example, of, hey, I need an insurance claim processed in 5 seconds. And if the end-to-end latency is not working out, then I need to know because I need to put more hardware on, et cetera, et cetera. So you can actually set that kind of alerts in this monitoring screen and set an alert for processing time. So that would be the ops functionality of it. And I spoke about real-time dashboard, so you can actually take a stream and connect it to a real-time dashboard. You can say, well, I want this parameter on the x-axis, I want that parameter on the y-axis, so you have temperature, pressure, you have stock values, you have min-max, all of that on in real time that you can watch and set thresholds and watch for threshold crossing events. We're also working on how we can inject a historical stream and do parallel comparisons of what happened exactly last year during this time versus this year. Black Friday may be a great case for doing that kind of analysis. So there's this constant evolution of this platform for that kind of functionality. I'm not going to go too much into this slide, but here's a breakdown of one particular deployment scenario in terms of what it actually had. So there's Kafka, there's RabbitMQ. We had both in that particular installation. We had Tomcat. So the Tomcat is a web server. We have Storm, Zookeeper, Graphite, Elasticsearch, Couchbase, all of those in this cluster. And of course, all of that is managed and for high availability. So finally, here's a different rendering of the same thing. We all talk about a big data lake, but I think we think we need a big data river as well. So this would be the big data river, where all of that functionality is available on the bus that I'm calling the river now, where you need to filter, transform, analyze, and all of the different parts of the enterprise, all the databases, all the analytical warehouses, the applications are all able to send data in, get data out, talk to each other through the bus, and also do live analysis and reporting and analytics on that. So that would be another rendering of the same thing, of the enterprise data bus with Hadoop at the center, synchronized with everything else. So couple of quick announcements. We are definitely hiring a lot, so feel free to come by in our booth. And the first, we've written a book called Learning Storm, and the first 25 people who come and ask for it, Larry Pearson's there on the backside, will get the free book. We only have 25 copies, that's why we had to do some filtration here. And the demo is available on booth S9. Okay, so that's my presentation for today. Feel free to ask questions. We have 7 minutes more, if there are any questions. Go ahead.
Is it open source? I know it's
The platform is not open source. It's based on open source technologies. There's going to be watch for the news. There's going to be something available for free soon. Okay. Yeah. Loudly, please. Yes.
Essentially, you're going to transfer all the downstream bytes, right? So as you're reading stuff and you're transferring everything, that implies that you need to have as much data processor ability to transformation phase as you have to store, right?
Yeah, we're talking about transformation here, right? The transformation is a tactical function. In case data comes in a particular format, you need to massage it a little bit before you land it somewhere else. You can do anything you want to the data. So you can, if it is going downstream to an application that is not secure and you want to, let's say you want to mask some field, okay? It's part of a data governance initiative, right? You want to know where the data is going and apply security on it, do some basic processing. If the more and more you do complex things in real time, it will bog down the throughput, right? But you can do something like that. Mask a social security number. If you know you're reading from a very sensitive regulated database and you're sending it into more insecure zone, then apply transformations which will suppress the private data. Okay? Anybody else had a question? I'm available back of the room for a few minutes in case you need to, so thank you.